Today we're going to look at the idea of how accurate is accurate enough. What do you have to do when you're playing in a market of some kind to come out ahead? Going to start looking at a couple of foundational models here to understand what's going on. First thing we're going to look at is a simple 50% coin toss. And assume in this world, if it's a 50% coin, and we have information that the coin is going to come up heads or tails 50% of the time, it's an even bet, and we have even odds, right? So we're going to do a set of trials where we start with $100, and we can bet each time $1. Is it going to come up heads? Is it going to come up tails? What'll happen if we do that over and over? What'll happen if 50,000 people play that game once a day from January 1st, 2000 until the end of 2024? So for 25 years, we're going to flip a coin every day and bet $1. What happens? Well, what happens, if we look at this, all the way on the very left here, that zero, that's people who completely break the bank, right? We're talking about total failure here. So these are people who completely break the bank, right? The risk of ruin that people talk about. And the idea is, right, if you get down to $50 because you just lost 50 in a row, let's say, you can still fight your way back up to $100, right, if you win the next 50 bets in a row. There's a way to come back. But if you break the bank, if you're completely ruined, there is no coming back, right? You can't come back. It's a game of attrition. So if we keep playing this game day after day for 25 years, a sizable portion of the population is going to lose all their money and be completely ruined. And if you look at the top here, right, it's more than 10,000. We'll come back to that later. But, you know, it's upwards of a quarter of the people who are playing this game then who go completely bankrupt. So this is with knowledge, with 50% knowledge of what's going to happen every time. Another way of thinking about that is you could just bet heads every single time. If you just bet heads every single time, you're going to be right 50% of the time. You don't know which 50%, but in the long run, you're going to be right 50% of the time. So this is just flipping that coin every day, what you'd wind up with. But what if there was a slight defect in your information? What if you were actually wrong another 0.75% and you were only right 49.25% of the time? Well, what you see is that if that is the case, suddenly over that same time span, not only are the average earnings much lower, but more than 60% of everybody who's playing this game will go bankrupt. That's the value of 0.75% of certainty, is we go from maybe a quarter, not quite a quarter, to more than 60% of the people who engage in this would go bankrupt using this strategy and with that defect in information. Let's go in the other direction. Renaissance Technology claims that they're right 50.75% of the time. What would this look like if that were the case? And what this would look like is we'd have a far better distribution, right? So think back to the 50%, which is what we've got here. And now with only 0.75% increase, suddenly the number of people who go completely bankrupt is down to 1,500 out of 50,000. Right? That's not very many. That's about 3%. 49.25%, over 60% of the folks went bankrupt. And then just with 50.75% accuracy rate, 3% will go bankrupt. That's amazing. We'll be completely ruined. The other thing is just eyeballing this here. The center of our distribution, the center of our histogram is something like $200. And we all started with $100. So 3% of the crowd goes broke. On average, then the median person here, it's not quite median because it's skewed a little bit to the right, but the median-ish person has made a little more than $200. So doubling your money, right? This is fantastic. So we've gone from probably losing most of your money, probably going bankrupt, and even those who made money didn't make much money, to suddenly we're able to get out here and everybody can benefit. So we look at the risk of ruin overall, right? 49.25%. Risk of ruin is 64%. 64% of these folks are going to be absolutely ruined playing this game. If they're right, 49.25%. 50% break even, right? 21% are still going to be ruined. But we increase the information we have so that we can win this even toss and even payback, even odds payout 50.75% of the time, and suddenly we're down to a 3% ruin rate, right? There's an exponential curve here. So the thing to take away is that the benefit of information is exponential. It's not linear. We want as much information as possible. And most importantly, a tiny bit of information can make a huge difference. So other thing we're doing here is we're doing just a simple betting strategy. Every time we bet $1, no matter if it's our last dollar, no matter if we have $10,000, every time we bet $1. So let's modify that a bit. We're going to go and do a 1% strategy, which means we will bet 1% of our bank no matter what on the next bet that we're taking. So here's how that changes that, right? So here's our 49%. Actually, it says 49.5%, but I think it's still our 49.25%. With a 1% betting strategy, reality is now no one's going to go broke. There are going to be a lot of people with like $1 to their name, but you're not going to go absolutely broke. So it skews this thing quite a bit. It skews the shape of this, right? We go back to the shape of the simple betting strategy. Lots of people went broke, and then we've got this kind of normal distribution-ish. It's not really normal. It's normal-looking distribution centered around maybe 100, a little after that, for those who survived, right? Which makes sense. If you don't go broke, your estimated value is going to be $100. Asterisk, if you don't go broke, right? Here, no one goes broke, but our estimated value is decreased. So suddenly our mean and median values are much lower. However, everyone's still in the game. So the point being for you as an individual, if you do this, it's going to significantly decrease your chances of losing everything. Because we go back and look at the high end here, we've got a lot of folks over 400 on the standard betting strategy, and we go and look at this 1% strategy. It's now going to be a much lower. So we also, the trade-off is we're cutting off the high end of that distribution as well. So we're buying safety at the expense of high-end performance. So if we look at our 50%, right, this is our break even, where our estimated value, once again, is 100, which is still going to be absolutely the same here because we're not going to lose our bottom end. And we have a very long tail to the high end. We can't even see it here, right? But the high end goes out and out and out and out and out. So think about the name of this channel, right? Kurtosis. Kurtosis is really about the pointiness, or put a different way, the length of those sides, right? That go out and out and out and out and out to the side, how long those tails are. And so we've got a really long tail. We can see stuff going out, in fact, to the 2,000 range out here, right? So some folks made a huge amount of money, and then everybody who would have been on the left side of that distribution is now compressed into this little tiny range, itty bitty. So a little better. There's some folks who are turning in some high returns, and everyone's saved from ruin. But what if we combine the two? What if we combine a 0.75% information advantage with that 1% betting strategy? Suddenly, this is looking a lot better, right? We have a sizable number of people out here at $1,000 or better. We can even see the curve getting out here at 2,000. And similarly, we have a lot of people who've been saved from absolute ruin here. So this is a pretty cool return. We're going to take a look at one other way of doing this. So clearly, all right, what we're seeing here is information is valuable. Information is extremely valuable, and the betting strategy is valuable. What you do with the bank that you have, how you expose your remaining money to risk is very important, because unlike a distribution with two sides, right, if you think about it, this side is a 0. As soon as you go down here, it stops. You don't get the chance to take a random walk and win. A certain percentage of people who get down there would make their way back up eventually. And as soon as you cross zero, in the real world, we don't have infinite money. So that stops us from doing that. So when you think about expected value and think about it in a purely arithmetic sense, the importance of avoiding. So looking at this, what we have is called the Kelly criterion. And in this case, everybody's happily just got $100. How did that happen? And the answer is nobody placed any bets, because this is the 50% information and 1-to-1 odds. So there is absolutely no benefit to betting. Think about that a different way. The expected value is $100. You start with $100. Why don't you just short circuit all of the trials through making these bets and just keep your $100? That's what the Kelly criteria led us to do. It's very simple. So looking at this, what we're doing is we're taking the expected return, and then we're taking the odds, the net odds, and we're creating a fraction out of this, and we're just applying it to how much of the bank is left. So if we know our actual win percentage, right? Our actual win percentage here. So that gives us an adaptable ratio based on the rate of return that we've been experiencing historically. So we can also adapt it based on what we've been seeing, right? We know that we're 50.75% accurate this week. We adjust it. We're 55% this week. Maybe we change that fraction. We're less accurate this week. Well, if we're below even expected value, we probably shouldn't be making any bets anyway that aren't hedged in some clever way to recover the value. But as a result, as soon as we get above 50%, it makes sense. And looking at this, 50.75%. So this is kind of hard to read, right? Because the histogram is clustered so hard over on the side here. So almost everyone is less than, kind of hard to say, 125, 250, something like that dollars. But the interesting part is look at that tail on the right. The reason our graph is going out is because there is some data there. So someone using this method out of our 50,000 simulations managed to bring in $35,000 doing it, finding that optimal size. And that's the point of the Kelly criteria. And then finally, if we look at, once again, we've got 51%. It's crazy. So not only do we have almost everybody didn't go broke, and we can't really see what's happening on the low end from this graph. But what we do see is there's also a measurable number of people who got out there making $40,000 or better, maybe $45,000 from where this X scale is dragged down, right? And we'll look at that table in a second here. But the point is the value of that information. So suddenly we're looking at even a 1% increase in information coupled with an adaptive betting strategy, even using a simple coin toss game. Those two things get us exponentially greater possible returns, and it limits the damage we can do on the downside. So these are important things to think about. So to wrap it up, let's look at kind of the overall performance here, right? A table of everything that's going on. The important things, right, when we really think about the ruin percentage is a really big deal. So obviously with the static strategies, we can see up here, we're in the 60%, we're 63%, we're 22%, we're 3%, especially the 63%, just not having that 0.75% of accuracy information, almost everyone is going to go bankrupt and suffer complete ruin following this strategy. And even if you look at both the mean and the median amounts of return that the folks are getting off this, it's not very good, right? On average, it's just not creating value. We look at clearly the static 50-50. As expected, the mean is 100. The median is actually a little less, and we find the distribution on that skewed, if you remember, because the people who go bankrupt don't have the chance to come back, which would be part of that normal distribution. So we're losing a little bit of the curve on that one side. A little more information, right? 50.75% in a static context here. With a static betting strategy, so that's $1 each bet, suddenly our mean is double, our median is doubled, our deviations increased, and our max is increased, right? So it's a little better scene for everybody. So clearly, more information is better. But what if we cut over to a smarter criteria at that point? Rather than just betting $1 a pop, what if we use the Kelly fraction to figure out how much we should bet based on this return that we know we're getting? Right? And we'd understand this if we're playing in markets or we're doing some other type of behavior by literally looking at what have been our returns to this point, right? How often are the bets that we make right or wrong? If at the end of a certain day, tomorrow, we say equity X is going to close up or down, how often is that right? How often is that right? It's a simple thing to do, depending on what we think of as truth and how many truth states. We start getting into multiple states, such as going short, long, or out of the market. It gets more complicated. So how we think about truth, not truth, but so how we think about correctness kind of changes over time. But point being, 51% now. Look at our mean. It's up to $1,300, right? Our median. So this is, of the mean, if you remember, is just the average. So really high numbers can throw that off. The median is, let's just pick the whole crowd of people. What are the folks in the middle seeing? Yeah, they're making 3.5 times. That's kind of cool. Deviation, once again, is actually a little less. And then the maximum that people are seeing, we're suddenly up to $240,000 as a max. So we've preserved that long tail while prevented most folks from going bankrupt. So that's that's a cool trick, right? That's really kind of a cool trick. And then we keep running with this idea, right? We go up to 51.5% accuracy. Suddenly, the mean's $38,000, right? We just jumped from $1,300 to $38,000. The median, same thing. It's not just because the very rich got richer when they were doing this, but everybody picked up. So the median's $1,900. The deviation is through the roof, right? We're at 1.1 million now. And the peak, if you look at that, that's 244 million. Our peak winner is now 1,000 times larger than before with a 0.5% increase in information. That's the only thing that changed. And then going to our 52%. So we're going up another 0.5% of accuracy. Suddenly, our mean is out here at $2.8 million, right? The median is at 20,000. Deviation is at 200 million. And the max, the person who's out here at the very end of the curve with the maximum amount of money is at $40 billion. $40 billion, right? That's starting with a $100 bank. So think about that for a second. If in 2020, no, not at all. January 1st, 2000, we start playing a game every single day of, is a coin going to be heads or tails? Think about it as betting in the market. Is a certain equity going to be up or down tomorrow? Although it's not 50-50, we'll use this for the example, right? If you had no further information about what was going to happen, your expected value after 25 years of playing this game is less than $100, because there's also a pretty good chance that you would have gone completely broke, right? And even the remaining estimated value is only hanging out around $100. And if we look at our table, the maximum with this 50%, 50-50, no extra information that you would get playing this coin flip game for 25 years, the maximum in this example was only $428, interestingly. I honestly would have thought it would be higher, but that's what we got in our simulation. So adding a couple percent, right? Just adding a couple percent of information, adding that extra 0.75% of information made some change, and in particular, it reduced the rate of ruin, but the maximum earner was still only up another $160 over even Steven, right? And then the average earner made about twice what they did otherwise. But as soon as we start adding in a little more thoughtful betting and bank management, suddenly adding information does amazing things, right? Going from this 50-50 break even after 25 years, you still got on average about $100 to your name after 25 years of doing this. Adding 1% accuracy, so somehow learning an additional piece of insight to let you get 1% more accurate than a break-even coin toss is going to, over that 25 years, turn that $100 into about $250,000 for the peak earner, and for the average one, about $1,000. But picking up an extra 1% over that, so now we're at 2%. You're correct 52% of the time. We go back and look at our chart. Our peak is now $40 billion. Our median is 20,000. Our mean is almost $3 million just betting $1 a day on a simple coin toss. I take that back. It's no longer $1 a day in that scenario because our betting scales as well along with the bank. So the more money you have, the bigger a bet you can take. And the less money you have, the less of a chance you're going to take. That simple concept combined with 2% information is the difference between $100 and $40 billion. So when we hear someone like Renaissance Technology say, they're right, but they're right like 50.5% of the time or 50.75% of the time, I've heard. Think about the power of this example. That might be as right as you have to be to make billions of dollars over the long term.